Okay, so we're going to save the mental math for last, or maybe not do it together this time because the librarian is coming. We've got 20 minutes to get through this, so we'll save that for the end if we have time. Otherwise, we might be skipping the mental math today. Okay, so today you know how we were doing ratio boxes yesterday. Today, being lesson 54 rate word problems, we are going to use a similar thing to the ratio boxes to cover rates. And once again, I realize that looking at this, you really just need to do 55 times 3.
This is so easy.
However, we are learning a method of solving problems that can be in your math brain toolbox, and so it's about learning the method using simple examples. So, humor me and make your boxes. So, if Mr. Gomez drives his car at an average speed of 55 miles an hour, how far will he drive in 3 hours? So, a rate box, as mentioned, is pretty much just like a ratio box, except we're talking about rates of things, which mathematically you do in a very similar way to ratios and fractions.
Is it also kind of like input and output?
Yes, kinda. So, one column be for your rate, the other column be for the actual number. I'm gonna do a number sign with the space I've got, and then moving forward, I'm just gonna say AN. Actual number, right? And so the things that we're talking about here are distance, so miles, and time, which are hours. So our rate that we go at is 55 miles for every 1 hour. So we have that information. We know how many hours we're going to go. So it's 3 hours. And then the question here, the information we don't have, is what is the distance he's going to drive in those. So we could just bring this over and make it into sort of a ratio rate kind of equation.
Is it like cross multiplying?
Yes, it is the cross multiplicative goodness.
Oh, yeah.
So thinking of it as a ratio, basically this one's 55 to 1. This one is blah 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 to 3. And essentially for every one of these, there's going to be 55 of these. So doing our cross multiplicative goodness, well, we end up with 1 times d, which is just d. Sorry? Yeah. Oh, it's so similar to yesterday, yeah. So, except today we've got 3 examples. Yes? Oh, okay, sure. And then that's going to be 55 times 3, because we're multiplying those. And so, you just do that out. Getting so is the answer 165? Goodness, no! 165 miles!
Every 3 hours.
For 3 hours.
A great answer would be Mr. Gomez drives 165 miles in 3 hours.
Yes. Very nice. Very good, guys. Yes, that would be a great answer. This is a acceptable answer. 165 is a terrible answer. All right. And so now that we've got the method down, let's see about having you come up with your own rate box for solving this problem, which is really almost exactly the same as the last problem. So if Mrs. Akita's car averages 24 miles per gallon, then how many gallons of gas will she use on a trip of 300 miles? It's similar, but your missing information will be in a different spot this time. So I'm going to give you a moment to construct your own rate box. Figure out what's the information you've got and what's the information you're missing. Make a ratio equation based on that. Do your cross-multiplicative goodness and solve. Sounds like a lot of steps, doesn't it?
No, but it is not.
But they're all very simple steps.
Hey, how do you write gallon in a short form? How do you write gallon in short form?
Oh, G-A-L. G-A-L. Gal. Okay, fine. It's sort of funny, yeah. How many gals we got in here? Okay, well, I think that probably gave you enough time to at least make your box.
Wait, oh yeah, it is in a different spot.
Okay, well, allow me to demonstrate then.
Do we write the answer as a decimal or fraction?
The book gives it as a decimal, but it sort of makes more sense as a fraction.
Okay.
Yeah.
So the fraction would be a decimal?
Yeah, I mean, I'm gonna do it. I'm gonna get it to where it is a decimal, but we can look at that and say, well, you know, that would kind of be more sensical.
Okay, I'm doing fractions.
Okay, so we've got my rate column. We've got my actual number column. I've got two things I'm working with here. It really doesn't want to put it right in the middle, does it? Oh! There we go. Yay. Alright, and so then we've got my...
What's A-N?
Sorry?
What's A-N?
Actual number.
Oh.
So we've got our rate, and we've got the actual numbers we're working with. So the rate is miles, the distance, and the amount of gallons it takes to go each mile, or amount of miles it takes to go for each gallon, I should say. So our rate is 24 miles for every 1 gallon. We know we are going 300 miles. Then what we don't know is the number of gallons. We'll just say that is G. So then we can make our equation. 24 over 1. Those are pretty simple because you're cross multiplying by 1. That was very basic. Percentage one. Next one we're going to do is percent boxes, and that can be pretty simple too because you end up with 100 down here. So you do a lot of multiplying things by 100, which is really simple.
Wait, does the piece up here that's applied to this?
No, you can get half a gallon. Say it just in case that was. Just in case that was the answer, that it will be half a gallon. Okay, that's not part of this conversation. Please do not distract us. Alright, so cross multiplying those guys. Ooh, edgy. And that was
super edgy.
and that was curvy. Okay. So that will get me 24 times G equals 300. Then I divide each side by 24. So I'm going to set myself up a division problem over here. Give myself a little extra space. Other than my edgy triangle kind of get in my way there. And so no groups 24 and 3, but there's 1 and 30. And so then that will get us 60. And so I can fit 2 of those in there. So that'll make 12. Uh-oh, I'd better add a decimal. Hey though, and then bring that down. But hey though, a little mental math. I know that 10 times 24 is 240, and 120 is half that much. So that would make that a 5. Okay, yeah. Alright. So then that gets me to, well, 12.5 gallons. But you know, if we're talking about gallons, like 12 and a half kind of makes more sense.
I don't think they refer to it.
You don't really say, oh, well, I'm gonna need 12 and 5/10 gallons. So no, people don't talk like that, no. Okay, we got 10 minutes for this last one, and it's a bit of a doozy. It's a 2-parter. We will use the information that we gain from part A to get part B. The sporting goods store is definitely not in California because they are paying far less than the minimum wage. Like half the minimum wage. Boo. Okay, but I'm not going to get into a tirade about the minimum wage. We're moving forward right now, and I think we have just enough time to get this done before the librarian shows up. Alright, so Hannah works for 8 hours at a sporting goods store and earns a total of $68. What is the hourly rate of pay? But now, I know. Anyway, we won't go on a big thing about the pay there. Ooh, I probably don't need to have that big of a box. Okay, so I know that we're getting a unit here. I know that we learned before that it'd be pretty simple just to look at it and just see it's 68 divided by 8, But we are learning a method of solving things. So humor me and make text boxes. Try to do it faster than me. If you didn't, then please do. And then we've got one thing for money. Well, if I'm telling you otherwise, then you thought incorrectly, and please make a box for these. Yeah, I mean, I'm saying, yes, you can solve it like that, but we are learning a method today.
I was saying that I thought we only needed to do it for B.
So we have 5 minutes. Is this a good use of our time? Okay, so the rate here. So we want the hourly rate of pay. So we want to know how much will be for $1, or for 1 hour. We know that got $68 in 8 hours. We'll say P for pay. So we'll do a little cross multiplicative goodness. We will end up with this equation. It's actually pretty mentally mathy, because we know 8 times 8 is 64. And we know that the 4 that we're left over with is, well, half of 8. So $8.50 per hour. Oh, I know. I'm not gonna comment too much about the injustice of the world on this one, though. Okay, then, so now for part B, use her hourly rate of pay to find out how much she will earn if she works 30 hours. Yes, this is all about making boxes. That's what the lesson is. Please do so.
But you don't need a ratio.
I have been over this several times. I'm not going to say it again. I have explained what we're doing like 3 times. I'm not going to try to justify this again. Okay, so money, hours, we have our rate, just say 8.5, since we're just doing the math, for 1 hour. So we want to know what it's going to be for 30 hours, and we'll make that P again. They put T in the book. I don't know why they said T for the money. Why say T for the money? Okay, so a little cross multiplyingness will get us to P equals. Here, I'll do it like this: 30 times 8 5/10. So, oh, actually, I could do this. I can just do it from up there, and so I can say, so I do a little shortcut here. So 15. This is 24, 25. Okay. So that will get us $255. For 30 hours. Yeah. I know. Like I said, I'm not gonna talk too much about the injustice of the world here, but yes, that's pretty pitiful. Alright, and yeah. Wouldn't happen in California because we've got laws about that sort of pay. Alright, you wanna try to see how far we can get with the mentally math?
Yeah.
Alright, mentally math!
Let's get mental.
Okay!
Steam ahead.
Full steam ahead! Alright, I'll take a couple of deep breaths. Let you get a couple problems ahead of me. Let's see, I'll go out and see if okay, well, go! Hey, you got that right now. Okay, so looking at this, it's kind of like 16 plus 2 is $18. Then this one, we are dividing by 10, so our decimal goes 1 to the left. Boingy. So that'll get us 1 and 275 thousandths. So looking at this one, a few different ways you could do it. I did cross multiplicative goodness to do it in my head this morning, but really you could look at this and say it's the same as 3. This one's the same as 3 halves. So so multiplying each one by 4 would get me W equals 8. And metric conversion. Okay, 1.5 millimeters to centimeters. Ooh, we're dividing. We're dividing by 100 though. Uh-oh. So that would actually be 1.015.
I love metrics.
Aha. Say centimeters. Excuse me. Oh wait, meters. I was thinking millimeters. I'm sorry. What am I doing? I saw millimeters for some reason there. Nope. Sorry. Multiplying by 100. Be 150 centimeters. Excuse me. That was. Yeah.
Oh yeah, I thought there was millimeters.
100. For some reason, I just saw two M's. No, it's 1 M. Meters. 2 centimeters. So yeah, you just multiply by 100.
Why don't we use the metric?
Okay, so yes, we won't have that discussion right now either. Don't have time, but yes, I agree. We say you're preaching to the choir, sir. Okay, so then this would be 30 minus 27 equals 3. Uh-huh. Then this one would be 1/10 would be 9, so 3 times that would be 27. And then remember the formula for these, and I know I don't need to do the first one. Since there's probably 1 times 2 times 3 times 4 times 5. But really, you could just look at that as 6 times 20, right? Yeah. Just taking these and taking these, putting them together. There's a few different ways you could use the commutative property to rearrange those to be more mentally mathy. So the answer to this would be 120 years old.
Imagine if someone actually wrote all of that.
Okay, so let's see. These first two will be 20ths. So looking at this, it would be 15 20ths plus 8 20ths is 23 20ths. Improper. 1 and 3 20ths. So then this one would just be 15 20ths minus 8 20ths would be 7 20ths. This one's got a little cross-cancel-y goodness. So you'd end up with 3 10ths. And then keep change flip. No cross-cancel-y goodness to be had there, but so you end up with 8 15ths. So improper. Oh wait.
Wait, 8:15?
Oh, sorry. 15 eighths.
Yes.
Excuse me. So that'd be 1 and 7 eighths. Oh my goodness, we got through everything. She's 1 minute late. Okay, here I'm gonna stop it.